Alright, welcome to HVAC lesson number 4. In this video here, we are going to be going over the wiring for my Fedder's weather wheel. Or in this case, if you guys want to see like my GM when I do get it, or when I get my comfort air, feel free to ask me. And once I get those air conditioners, I will do a wiring video on those as well. But anyway, this one's going to be an easier one for you since we already have some of the wiring simplified, due to a fan motor issue with the Fedder's. So anyway, let's go ahead and get into it. So right now we're looking at my Fedder's wiring. And as you can see here, it's pretty simple on these older units. It's not like the modern ones, not like anything like this, where you got circuit boards and stuff like that. This is actually pretty simple. You got nice thick wire to work with. And you also have spade lugs, which makes it a whole lot easier. So anyway, let's go ahead and start off with the power delivery source, which in this case is the power cord on 115 volts in 208-230 units, or in central air conditioning, it would be the main disconnect switch. So anyway, because we have a 115 volt unit here, that's what we're going to stick to. So anyway, this is the power cord right here. As you can see, we have our 3-prong grounded plug in case if a short should occur, because this is an all metal unit. So you must have some kind of grounding source to be able to safely ground and properly ground the unit in case if an electrical short or failure should occur. But in this case, we have our grounding right here. So no, it is not plugged in, as you just saw. So anyway, the power cord is the power delivery source on 115 volts units. So that's the power input. And the power cord delivers power into the control panel here, which is what gets the HVAC system to work. So if you look carefully here, you can see we have our hot and our neutral. So in this case, our neutral wire would be this one here. As you can tell, well, actually they're both hot wires. So anyway, in this case here, because this is a 3-prong unit, you don't want to mix up your wiring, because this one right here is our neutral. And then this one is our hot. So anyway, the power comes in. And as you can see, it goes into this wire here, which then hooks up to the thermostat. Well, actually, it will come back. So we got that a little mixed up there. So anyway, this is our power input here, which then sends power along to the compressor. And then this one also delivers power to this wire here, which therefore will engage the thermostat. And then these two wires here will then bring power. Well, the white common wire here will bring power directly to the compressor, which you can see we have that open right now because we just did a previous test video where we did the electrical testing and ohming out a compressor. So that wire comes from over here at the control panel, and power is delivered to the compressor, to the overload protector first, and then to the compressor. And then the blue wire, as we explained in the previous video, brings power from the thermostat to the run capacitor, which is this guy right here, 370 volts, 25 microfarads, and it gives the capacitor the charge needed in order to start and run the compressor. So then these two wires here, the black wire delivers power to the main winding of the compressor, which starts it, and then the yellow wire brings power to the main run winding in the compressor. And then common is where the power is fed. So in this case here, you might think, why is there a main motor winding? Well, we're going to be covering that in the next video when we test the fan motor, which we already know it failed, by the way. But this compressor has what's called a PSC motor, which, in case you're wondering, the condenser fan motor right there is also a PSC motor. So if you're wondering, well, what does PSC mean? It's a permanent split capacitor motor, which means the windings are split, just like in a split phase motor, except there's no centrifugal switch, because these motors are governed by a capacitor instead of a centrifugal switch. Now, some split phase motors combine the technology. So, of course, if you've seen like Dayton shop fans, air circulators, things like that, they got these big motors. I mean, you're talking a quarter horse or bigger. Obviously, you are going to see a start capacitor, but you're also going to see the centrifugal switch, which will disengage the start winding on a split phase motor. Now, if you look at a PSC motor, which you can't see on this compressor, but you can see on the fan motor, the windings are also split. But instead, both windings are engaged at all times, which is the main difference between a PSC motor and a split-phase induction motor. So yes, they're both induction motors, in case if you were wondering, but the main difference between a PSC motor, or permanent split capacitor, and a split-phase motor, which may have a start capacitor, but no run capacitor. So you may be wondering, well, is this capacitor a start or a run capacitor? It's a run capacitor, but it serves the purpose of both a start and a run capacitor. So it starts and runs the Emerson motor in my Fetter's compressor, which in this case, this is an AJ, by the way. So, and also, some fan motors might even be split phase induction. So it's like Dayton shop fans, you'll see them with that. But like I said before, the main difference between a split phase induction motor and a permanent split capacitor induction motor is the PSC motor lacks a centrifugal switch, because the run capacitor both starts and runs the motor for continuous duty. So in this case here, yes, these are PSC motors. Are they split phase motors? They are to an extent. But do they have a centrifugal switch? No. So anyway, I hope you guys found this one useful, where we went over the wiring a little bit. And I'm also, before we close out the video, I'm going to show you the fan wiring as well, which unfortunately the fan motor had failed, but I'll show you the wiring anyway. So I'm going to sit you guys over here for a minute. Move my light back over, make it easier. So right here we have my Fetter's fan motor wires. So in case if you were wondering, the ones that go to the capacitor, right here, they're shorter. So anyway, so the black wire here, this is obviously your main power wire right here, which we don't know if these are shorted or not, but we will test them in the next video, which will be HVAC lesson number 5, testing an AC fan motor for faults. Or in this case, we're going to be testing a failed motor to see why it must have failed. So anyway, I did take apart a bench 3-phase grinder at Voltec, and we found out one of the phases was knocked off, causing the motor to get stuck and just run constantly without turning, which ended up burning out the two of the windings on that motor, or 2 of the phases were burned out, but the one was fine. But my Fetter's has a similar problem, because the run capacitor, even though yes it's a single phase motor, the main winding, I think it was the main winding that got knocked off, and it caused the motor to spin so slow, and it just smoked right away. So I think the run capacitor had failed, but I will show you how to test that in another video. I mean, some of these we might be doing at Tech. I might be doing some of these at Tech, where we can get some further detail on how to fully test them. But anyway, let's just get to the wiring here. So this is your main power wire right here, which is the black one. So power is fed from the control panel along this wire to the fan motor's main winding, which gives it energy in order to start. So that's our start wire right there. And then we have our 2 speed wires, which in this case red is low and then orange would be high. Or I may have gotten those mixed up, but we'll find out when we put the new stator and windings in. But anyway, thought I'd just show you my Fetter's fan motor wiring right there, just to give you guys an idea, since we were going to include it in the video anyway. So I hope you guys found this video helpful. As always, I appreciate your guys' feedback, and we'll see you in HVAC lesson number 5, which is testing the fan motor for faults and or possible repairs that can be done. Thank you for watching, and peace out.